All right, good morning, ladies and gentlemen. Today we continue volume, and today we're going to sort of take what we know about, that we learned in the first section about models, and really start to more fully understand concepts of volumes and relate them to multiplication and addition, right? We're going to start to put some formulas into use today. And so just some things in your notes to highlight and to remember, right, that volume is a measure of the space inside a solid figure. It is measured in cubic units, right? So if you take a box, it's how much fills up the box. If you took a pool, it's how much water fills that pool. Right? And then a cubic unit is the volume of a cube that has edges that are each 1 unit. Right? And so what we're talking about here is, here comes some amazing drawings, right? If I've got a cube, we're going to pretend that this is a perfect cube. That's not bad, right? So each one of these edges, that's 1 unit. That's 1 unit. All right, that's 1 unit. And then we've got some formulas. So if you know the length, if you know the width, if you know the height, you could calculate the volume by using the formula length times width times height. Or you could find the area of the base and then multiply the height. And we're going to talk more about these formulas individually here in the next couple of slides. All right. So here I have a box. Right, here I have a box. It is 2 centimeters wide. It is 3 centimeters high or tall. Right. So I'm going to put in red, I'm going to put what measurement it works with, kind of there next to it. And then the length is 4 centimeters. Notice that we use a cursive L, and the reason for that is, if you did not know, here I have a lowercase l and a 1. I want you to tell me which one is which. And you can't, right, because they look similar. So when we use L's in math to represent length, we use cursive L's. All right. So if we use the formula volume equals length times width times height, right? The length is 4 centimeters. The width is 2 centimeters. The height is 3 centimeters. Let's do this. All right, so I've got the length of 4 centimeters. I've got a width of 2 centimeters. And then I've got a height of 3 centimeters. And so when you multiply those 3 numbers together, 4 times 2 times 3, you get 24. Okay. The other formula here is a capital B times H, right? So that's the area of the base. That's highlighted down here, right? So what I'm going to do is I'm going to rewrite this, right? That's the area of the base times the height. And sometimes people already multiply the length and the width for you. So for example, in this particular problem, right, if we're talking about, right, the area of the base, that's this portion, like this bottom layer here, which happen to have measurements of 2 and 4. And so if you multiply those, the area of the base would be 8 centimeters squared, and then you would just do 8 times 3. Right? If there is a problem that to use that formula on, it will tell you, right, it will give you a number that has centimeters squared. And we'll see a couple of those in a moment. So these are the formulas. You're either going to do length times width times height, or the area of the base times the height. So the way that this kind of works is, right, if we imagine a rectangular prism, right, here's a cubic box. It should look similar to the one you saw in the first section. And we split it into different layers, and we find the area of just one layer, right? So this is the area of the base times the height. Right? So if we split this into layers, and I just take, right, let's say the bottom layer. This is one layer. Well, the area of this layer is 1 cube, 2 cubes, 3 cubes, 4 cubes, 5 cubes, 6 cubes, 7 cubes, 8 cubes, right? So there were 8 cubes down there, right? It's 2 by 4. And then we multiply it by the height. There are 1, 2, 3 layers. And that would be 24 units cubed. When I do this formula, I like to think of a loaf of bread, right? So if you take a loaf of bread, this is good old-fashioned white bread. Now I want a peanut butter sandwich, right? a loaf of bread has a bunch of slices in it. Right? This formula has us find the area of one slice of bread. Right? We find the area of the base of one slice of bread. And then I multiply that by how many slices there are. Right? By 1, 2, 3, 4, 5, 6, 7, 8 slices in this case, right? But I multiply that by the slices. Let's try some. So in these two examples, we'll do one together, then you can do one on your own. I'm going to do the easy one. You guys get to do the hard one today. So again, when there are 3 measurements or more than 2 measurements, right, and we're looking for volume, you are most likely going to be using volume equals length times width times height. So the length of this box is 4 meters. The width of this box is 2 meters. The height of this box is 1 meter. 4 times 2 is 8, times 1 is also 8, 8 meters cubed. Without this label, it's not the most correct it can be. Pause the screen and try the next one. All right, in this example, I got a volume of 5,520 cubic feet. My math is here, but I did a length of 23, a width of 12, and a height of 20 feet. All right. These last two examples are both examples of volume equals the area of the base times the height. Again, I'm going to do one, and then you guys try one on your own. So it's kind of tough to see in the slide, but this says feet squared. If you get feet squared, meters squared, anything squared, this is an area. This label tells me I'm going to use that formula. Right? So I'm going to do 16 feet squared, area of the base, times, right? We could flip this box up on its side, right? Times 12 feet, my height. So I have 16 times 12. So 192 cubic feet. Try the next one. Here we get a volume of 300 meters cubed. Again, you'll notice that when we have meters squared, that tells us it's an area. And 15 times 20 is 300 meters cubed. So your next steps will be to complete both of the practice buddies for 10.2 and 10.3. Come and see me with any questions. Have a great day.